Hey guys, we're here to talk about graphing linear and absolute value inequalities. Let's get started. Okay, so remember from Algebra 1, your four inequality symbols? Okay, so we have greater than or less than, greater than or equal to, less than or equal to. Those are four symbols we have whenever we graph an inequality. All right, so remember the type of line. If you see this greater than or equal to or less than or equal to, you have to use a solid line. If you have just strictly greater than or strictly less than, you'll use the dashed line. Now, when we talk about which direction to shade, these two symbols you will shade up, and if you have these two symbols, you will shade down. So you have to make sure you're reading your inequality to determine where do you have to shade in order to get all of the solutions to your inequalities. Okay, so we have the inequality y is less than 2. And I'm going to pick 2 points just to figure out where this line is. And so I use 0, 2 and negative 4, 2. And I know that this creates a horizontal line that intersects the y-axis. So with every inequality, you always want to have a test point. So the easiest test point to use is the origin. And I want to know if I substitute in the value y into this inequality, will it make a true statement? So when I plug in 0 for y, it says 0 is less than 2. Is this a true statement or not? And we know it's true. Therefore, this point is in the solution set. So I will shade below the graph. All right, so here we have the inequality 5x minus 2y is less than or equal to negative 4. We need to put this inequality into slope-intercept form so that we can graph it and also figure out where the solution will fall or where the solution set will be. So I start by subtracting 5x from both sides of my inequality. And so I have negative 2y is less than or equal to negative 5x minus 4. And then I divide both sides of my inequality by negative 2. Now remember from solving inequalities that anytime you divide or multiply by a negative number, that causes your inequality symbol to change directions. So here, instead of it saying less than or equal to, it now says greater than or equal to. So y is greater than or equal to 5 over 2x plus 2. So we graph this information. Here's the line we get. And remember, because it also has the equal to portion of the inequality, it's going to be a solid line. Now the next part is just to figure out where's the solution set. So I'm going to test the point, and the point I'm going to use again is the origin. So I plug in my values into my equation, and I want to see if I substitute 0 for x and 0 for y, will it give me a true statement? So here I have 0 is greater than or equal to 5 halves times 2 plus 2. And we want to see, is this a true statement? So when I simplify the right side of my inequality, I see that 0 is greater than 2. But that's not a true statement. So I know that 0 is not a part of its solution set. So I'm going to actually shade on this other side of the line. I'm going to shade above the line. All right, so here we have an absolute value inequality. Y is greater than negative 2 times the absolute value of x minus 3, and then we have plus 4. Okay, so with this inequality, you want to pay attention to the inequality symbol itself and then also think about your transformation rules. This is where we will start with this particular problem because this is its parent function. And so if I apply my transformation rules, I see that I'm translating this graph 3 units to the right and 4 units up. And also it's going to cause it to reflect across the x-axis, and it's going to have a vertical dilation of 2. So when I perform all those transformations, here is where the vertex of the top point of the graph is going to be. Okay, so I just translated the right side of the graph to get the following values here. And I know that absolute value graphs are symmetric, so I want to go ahead and just reflect the points across that line of symmetry. Now the line will be dotted because it's strictly greater than, and then we are going to figure out the test point. So like always, let's just use the origin 0, 0 to figure out where the solution set lies for this graph. I plug in 0 for my x and my y, and I have 0 is greater than negative 2 times the absolute value of 0 minus 3 plus 4. When I simplify the absolute inside the absolute value bars, I get negative 3. And then I know that the absolute value of a negative number is going to be positive, so it ends up being negative 2 times 3 plus 4. So here I have 0 is greater than negative 2. Is that a true statement? It is indeed. And so I know that the solution set will include the origin, so I'm going to shade above my line. All right, as we are moving through the video, remember to write down any questions you may have so that we can clarify them in class. So here's the next transformation. I encourage you to actually pause the video, see if you can graph the inequality, and then find your test point so you can shade the solution set. Okay, so here are the answers. Remember, we are transforming the absolute value parent function. So this is where we're starting, and this is where we ended up after the transformation. Remember, a good test point is to use the origin to figure out if it makes the inequality a true statement. When we substitute our values in for x and y, we find that it is an incorrect statement. It is false. So that means we do not shade in the region that includes the origin. We shade below the graph. All right, as always, if you have any questions, make sure you write them down. Thanks for watching.